Good afternoon, ladies and gentlemen. My name is Werner Jacobs, and I am working at the Antwerp Maritime Academy. And I will continue a little bit on the story of Marianne, but then I will put the focus completely on the ship. Um, I will tell you something about air quality and shipping, and that means I will try to focus on the points that are different from air quality ashore. What is now so special on air quality on board of a ship? I will try to identify the main pollution sources. I will indicate that ship's moving objects, something about the ventilation and the working and living on board. That is the goal. So for indicating the main pollution sources, I have stipulated here the engine-related pollution, cargo-related, and external pollution. Engine-related, of course, that is the engine exhaust. That's the first thing where we think about, but that's also operations in the engine room, and especially the handling of the fuel. I will come back on that in detail. So engine exhaust, yeah, you know how, I presume you know how it looks like. And okay, the only change we made over the last 30 years on this funnel is maybe uh, the bended pipes on top of it to guide these pollutants to an aftwards direction, hoping that then in that case we get less of these pollutants back on board. Um, this is the case, of course, where the funnel is placed aft of the superstructure of the ship. But for the rest, not too much has changed on this layout in the last 20 years, and we are still sailing like that. Of course, the composition of what is coming out, that might have changed over years. Luckily, it is. Another another pollution source related to the engine is the engine room. And the engine room is an area, is a space where there are a lot of connections made and where leaks are possible. But on top of that, we have there, of course, a huge running engine and other auxiliary elements like generators, like purifiers to purify the fuel, like boilers, like oily water separators. We are heating fuel up there. You can imagine that this area is also a zone where there are a lot of sources of possible pollutants, and that makes the engine room a very interesting space to do evaluation of the air quality. Because despite the huge ventilation that is present there, we are afraid that the sources which might be there are still more important than the ventilation can handle. And that is proven in this small table. In this table, we followed a vessel from Rotterdam on a voyage to the Baltic Sea and back to Rotterdam. We have measured there several VOCs, and what I compared here in this table is I made the ratio of the indoor concentration in the engine room, and I divided that by the outdoor concentration of the same pollutant. And what you see is that all these ratios are above 1, indicating that the indoor concentration is higher than the outdoor concentration, despite a huge ventilation of 70,000 cubic meters an hour, assuring 2 air changes every minute. Despite that ventilation, we still find this result. You see that there is one exception, that is the port of Wilhelmshaven, and that was the case because we were with the vessel too close to a coal power plant, which polluted more than the vessel, and that was the reason. There's another small exception for benzene, and that was in the port of Rotterdam, where the background concentration of benzene outside was relatively high, and that is why it is also under unit result. All the others are above unit, and that indicates that in this engine room there are a lot of sources of pollutants, which needs further investigation. We didn't went into detail or to look for the sources, but we know that there will be surely additional pollutants present. And finally, also related to the engine room are the fuel tanks. Fuel tanks that breathe according to day and night differences in temperatures. This breathing of the fuel tanks create under pressure, overpressure that should be compensated somewhere. So there's an outlet on deck. We placed there measuring instruments to see what is coming out of these breathing outlets, and we were surprised the amount of VOx that came out of that. And especially during the filling of the tanks, you get a large amount of pollutants. Don't forget that ships are sailing at sea on heavy fuel oil, and heavy fuel oil looks a bit like choco. The viscosity is relatively high, and we need to warm it up before we can use it to liquefy it. So there's always a day tank where we heat up fuel up to temperatures of 60, 70 degrees, and these tanks also permanently have a high emission of VOx on deck. Okay, then the cargo-related pollution sources, I think mainly cargo vapors, cargo operations, and work on deck. Cargo vapors, if you look to this CFD simulation where we studied the release of gases here just in front of the accommodation, then we see that these vapors go overboard. We think we get rid of it, but no, because aft of the vessel, because the vessel is moving after the superstructure, a certain under pressure is created, and so these vapors are sucked up again here and brought up to the highest level of the superstructure. And everywhere where there is a black arrow indication, that means that the direction of the wind is opposite to the relative wind direction on board. So it's not only because this is specific for tankers, that is the main pollution sources, or cargo vapors are released there on deck, but that can also be a leaking container, for example. You don't need necessarily to be on board of a tanker. It can be any kind of ship with possible pollution on deck. This is, of course, a tanker, an image of a tanker where you have, again, a lot of connections which you can compare with an engine room. So this is an engine room in open air, let's say. And then finally, the work on deck is also something where we were quite surprised, because at the moment we did measurements on deck, they were painting on the forepeak, and we have seen that our measurements were clearly interrupted or destroyed, let's say, by the work with the paints. These marine paints are very good paints, but they contain a lot of VOCs also. And then finally, the external pollution sources. We have seen already two, the one of Wilhelmshaven, Amsterdam, Rotterdam, sorry. But in any port environment, there is here or there a pollution which is related to the activities in the port, of course. And especially also, it might be that you're on the greenest ship of the world, but if just beside you there is a tanker loading benzene, then it might be that you have pollution from that vessel, of course. Another specific point related to ships is that a ship is a moving object. What do I mean with that? Everyone knows that the ship is a moving object, but we have to focus on the relative wind. The relative wind will determine the air quality on board. The relative wind is related to ship movement and the true wind. And both might change as well, ship movement as true wind. the true wind will maybe not change every 5 minutes, but you can imagine that when the ship is sailing on the river Skeld, that the heading of that vessel is changing continuously, and that does the relative wind will change also very fast, and that you have moments of good air quality when the plumes from the funnel are directed to an direction away from the accommodation, but that a few moments later you might have the worst condition that the flumes are uh, directing immediately to the ventilation of the vessel. And here, just an small simulation to give an idea of what I mean with relative wind. In this CFD simulation, we have supposed that the wind was coming from ahead, from the bow of the vessel, blowing aft. And you see that aft of the vessel, you see here this turbulence because of the under pressure aft of the superstructure. When the wind, and this is what this image is showing, the relative wind is only 1 meter per second, and we blow the vapors at a high speed out of the outlet, well, everything passes nicely over the accommodation. When we increase, however, the relative wind speed, we see that this plume is coming down. It takes some time to load it, apparently. That's a pity. You see that the plume came down, and that will, yeah, and more I increase the wind speed, the more the plume is coming down. And at 5 meters per second, you see that this plume is touching the top of the superstructure. Well, this is now exactly the level where the intake of the accommodation ventilation is situated. So at this moment and at this wind speed, we got bad air quality inside the accommodation just because the plume is pulled over the top of the accommodation. If I increase the wind speed further, you see that the airstream is coming down further and further. And at this level, with a 10 meters per second wind, we have the plume which is passing over the inlet of the engine room ventilation. This is where the accommodation ventilation is situated. This is the bridge, so we are now at the highest level of this accommodation of the superstructure. And the bad thing is that there is only one intake, and that's this one. And this one is situated on the port side, left hand, let's say. There is no intake on the starboard side, and that is a pity, because let's assume that we had one on the starboard side. We could imagine a system that automatically would shift the intake of the ventilation from port side to starboard side if the wind comes from starboard. So in an ideal situation, we could choose whether to use this one or the one on the other side, depending on the relative wind direction. Now we don't have that option, there's only this one. So we would propose to install one on the other side also, together in combination with an automatic system that detects, in function of the relative wind direction, which intake to choose. On the right image here, we have the ventilation intake of the engine room, and this one is in double. So here we have one on the port side and one on the starboard side. But there's not such an automatic system as I explained. The engineer officer has to change it manually. And so how is it done in practice? Well, one day he will use the port side, next day he will use the starboard side, and the day after he will use the port side again. So there is no logic why he uses port side or starboard side, and that is a pity. That's a missed chance in order to improve air quality inside. Onboard ventilation, we can distinguish three main units: the unit for the accommodation, engine room, and kitchen. The accommodation, um, sorry, accommodation, engine room, and kitchen are the most important one. They should be effective and powerful. That they are powerful, I'm quite sure. The effectiveness, I think that needs another research, because on my based on my results, I think the effectiveness can be improved. Also, recirculation and filters are used in order to improve the air quality in situations where the outdoor air should be polluted too much. But then on the other hand, I have here a minor ventilation circuit with the inlet changing room. Changing room is the place where you change your clothes when you come from deck and you go inside the accommodation. But the inlet of this ventilation system is positioned right above the venting uh, points of the polluted water tank and the thermal oil tank. That means all vapors that are coming out here are sucked immediately inside. I'm not sure whether naval architects are really concerned about air pollution on board, so this could have done better, in my opinion. Okay, and then finally, working and living on board. The crew is not only working but also living on board, is what Marianne also mentioned earlier, uh, namely for several weeks, months, and therefore I think on the TLV values we need to apply reduction factors, and all on top of that we also have more pollutants present on board of the ship. So research has shown that sea workers, as they work also on Saturday and Sunday, they work more or less 70 hours a week during periods of 2.5, 8.5 months. When we look to a TLV value, which is the official threshold limit for 8 hours, 5 days a week, we need to reduce these TLV values to a value adapted for that specific period of work for seafarers. And this formula is proposed. That means that in a case that seafarers work 70 hours a week, we should half, almost, no, even a little bit more, that we should have these TLV values to obtain a value which is usable for seafarers. That is for the TLV value, but on board of a vessel, we have, as we've seen, more pollution sources. And the problem was, how shall we take all these different concentrations and their according risk, how shall we take them into considerations? And we call that a cocktail of pollutants. Inside the Elgas project, we organized roundtable discussion about this problem with medical experts, and we have shown them this formula. This is the formula which you find in the literature, and it says that the concentration divided by exposure limit of substance 1 plus the concentration divided by exposure limit of substance 2, and so on and so on, should be lower than 1. The outcome of the roundtable discussion was that this formula is okay, can be used, but should be taken into account that the risk of substance 1 should be the same as the risk of substance 2. So for example, if both are a risk for lung cancer, okay, then you can make this addition, and then you can compare it with unit. If both are related to another risk, then this is not valid anymore. And finally, I looked to find a comparable situation where people are working and living for a longer period on a same platform. And that I found in the world of submarines. In the world of submarines, they define a 1 hour and a 24-hour emergency exposure guidance level, and also a 90 days continuous exposure guidance level. And I give you the example of benzene to explain that. So for the IMO, the International Maritime Organization, the TLV value of benzene is only 1 ppm. But for submarines in this 90 days continuous exposure guidance level, that value has been reduced to 0.1 ppm. So they use a reduction factor of 0.1 on these values. And that is something I think where seafarers and especially the IMO should also think about, and which might be a solution for the problem of working and living on board of a vessel. I'd like to thank you for your attention.